All right, so today we're going to be talking about the brain, right? So what is important about the brain and why do you really need to learn about the brain? Now, have you ever asked the question of, who are you? What are you? Are you real?
I ask myself that sometimes.
So, what are you?
I'm a human.
You're a human. What does that mean? Can anybody tell me, what does a human mean?
That I originated from Homo sapiens.
Okay, so that means that you're just a human, another one.
Yeah.
Awesome. That means that this individual right now doesn't have any personality. It doesn't have any way that dictates that he's unique. That's what the answer was. How does this makes you unique? Who are you? Give me features that makes you unique. Your personality. Your looks. Cognition. So let's give it on the personality end. Right? How's your personality? Fine on yours. Right? How do you build your personality? Nature, nurture, big words. What is that?
Genetics and then your environment.
Correct. Everybody agree? Yeah. Give me examples. That's what I expected. Examples. Nature, nurture, yes, I agree. What's the example?
Isn't that like how you're like when you're raised, like choose a character?
Yeah. I mean, we understood what she said. The problem is that when it comes into perspective of putting that into consideration, right? So here's a quick thing. Where do you live? In the United States of America, right? Especially where? In Miami. Yes? So in Miami, what does that mean? Almost everybody out there drives what? Cars. So you're expected to have what? A car when you grow older, correct? You're not going to see yourself walking in the streets because that, for some people, it looks bad, right? Not that it's a bad thing. If you go to Latin America, there are a lot more people walking than actually cars. So it's okay not to have a car, and you can be 20, 30 years old and not have a car, which is okay. You have a bike. Right? Even New York, right? So that is a normal standard, right? The other standard is the following. You see everybody with an iPhone, right? And most likely, what would you like to have? An iPhone. So in other words, you will have not evolved a lot because we actually want what we see. Correct? And we actually want what we cannot have. Right? That's pretty much it. That's what humans are. And whatever we have, we don't appreciate. Agree? And why is this? Why is this dilemma always happening with each one of us? That happens with each one of us all the time. And it's really simple. It's based on what you're capable of doing what? Seeing. What you're capable of hearing. I'm not even talking about listening. Right? And then how are you capable of personating that into your life? So every time you see a commercial, every time you see someone, you talk to that person and you get their opinion, correct? And the more people you talk, the more different opinions you get, or most of them, they kind of be pretty much about similar things, correct? Then based on that information that you have gotten from a commercial, from opinions of people, you actually made a decision, correct? Why? Why? Why do you let other people dictate what you like and what you don't like? If you like something or someone, why do you dictate other people to tell you what you should do and what you should not do? Actually consider. Because that is part of what? That is part of our evolution, right? We actually, unconsciously, whether you like it or not, we are paying attention to everything that we are doing what? Seeing, hear, and what people are saying to us, correct? Or as well as the way that you express yourself. How are you going to express yourself? The way that other people around you are expressing themselves. Does that make sense? So if you are surrounded by individuals who have low way of understanding or self-preservation, then that's the way that you will be. If you surround yourself with individuals that like to read and like to think or like to have challenges all the time, then that's what your personality will turn out to be. Is that works 100% of the time? Actually, it does not. Everybody is a different world inside their minds. But what is common to all of us is that we have millions and millions of what? Neuronal connections, right? Whatever makes sense to me, it may not make sense to you in the same way. We can have twins individuals, right, raised on the same environment, and they can come up with a different personality because they interpret the same visual, right, information, the same hearing information, auditory informations. They can interpret that into their own different thought process. Correct? When you do that, and when you put all that into accommodation into your brain, you think about what? Past events. So if the past events, you have 2 accidents, right? Because you were going above 80 miles per hour, then most likely next time you reach 80 miles per hour, the accident is going to come back into your mind, correct? And then you're going to maintain a speed of 79, right? 0.5, because it's about 80, right? I mean, so but you get the idea, right? So all you do is you actually relive whatever events happened to your life on the previous experiences, correct? And based on that, your brain automatically makes decisions and accommodate these thoughts, these processes. Some of them, they will stay within your mind in the short-term memory, like this class, or a long-term memory, like all the things that you keep using in the future. And eventually, that will influence what? Your personality. So you are what you're being exposed to, in other words, right? So whenever you think, when you think, right, you use all the brain power that you have. What percentage of brain do you use? What percentage of your brain do you use? Or what percentage of your neuronal connections do you use? And it's really simple. The more you have understanding of things, the more you look into things. The least that you understand something, the least worried you're going to be about things. So you're never going to think about that possibility. Does that make sense? So the more knowledge you acquire through life, you actually are tampering into a greater power of brain processing and usage. Does that make sense? So if you know a little bit about multiple things, you can specialize in one thing. But then you have all the other different type of views that you can see one single topic. For example, the topic of the brain. You see it, or I'm teaching you to see it in a way of what? Anatomy and physiology. But what about psychology? What about business? Business? Brain? And you have to be able to find a way that interests them so you can sell a product. So there are different ways that you can see one single objective from multiple perspectives. So the more knowledge you acquire, the more brain power you can use. Or different ways of looking at things you can have, right? That's what we do. So according to people, what people say is that, Einstein used about what? That's about 10% of the brain power, right? So that means that I'm using about 1.5. Correct? That's actually not true. There are certain times within our life that we are able to tap all the way to almost our full capacity, about 100%. And that's only in a few times. If you're completely concentrated, if nothing else is in your mind, if you completely go outside, you're spaced out on the outside world, and it's you and whatever you're trying to understand, things will come to you in a flash. Have you ever read something that you're interested, or just watched something that you're interested, that impacted your life, and until now, you can still remember and have a vivid memory of that information? That means at that moment, that got your attention, that allow you to access your maximum amount of brain power that you had. And you never forget it afterwards. Why? Because now you didn't create a short-term memory on the temporal lobe, but you're able to create a long-term memory. And every time you make a decision, probably, if it comes into that sort of area, then that memory will come back. Does that make sense? Inside the brain, there are 7 brain regions. What are they? Well, we have your cerebrum, which is your both hemispheres, right and left. You have your cerebellum, which is the one underneath the occipital lobe. That's the one that dictates most of your fine motor movement and commands. You have your diencephalon. And what does that word mean? Well, that word means what? Thalamus. So if you hear the word, or you see the word, or read the word thalamus, hypothalamus, or epithalamus, so anything with the word thalamus, that's referring to a specific portion of the brain, and that is known as the what? Diencephalon. Straightforward. Okay? So what is the thalamus? The thalamus is the main relay sensory center of your brain. I know it's a long word. Every single sensation that you perceive, both outside or inside your body, it is going to go through one door or one specific office or center. That is your thalamus, all sensations. And then those sensations will be spread out through the different parts of your brain. Means what? If I have a visual input, that visual input, the fibers are going to go through the thalamus, is going to interpret and then send that visual input all the way to the occipital lobe. That's where you associate or get the input of vision. Okay? The only exception to the thalamus is your olfaction. So you may want to write that down. So olfaction is sensory, but it does not go through your what? Thalamus. It's the only sensory one that does not pass through your thalamus. Okay? Now the next thing that we have, number 4, is your mesencephalon. The mesencephalon is actually made by 3 different parts, which are going to be the cerebral peduncles, your mammillary bodies, and your optic tract. So 3 structures that are part of or makes your mesencephalon. Number 5, we can just call it one word, and that is your brainstem, like the stem of a flower, right? So the brainstem is composed of 3 structures. Your midbrain, which is the middle, the pons, which is the olive-like mass, right? That regulates respiration, digestion, right? Heart rate. And then you have medulla oblongata. This one pretty much does everything in one. Respiration, digestion, heart rate. This one does all of it. That's the medulla oblongata. So those are 7 brain regions. Now, what are we going to do now? What we're going to do, we're going to talk about the 2 cerebral hemispheres. Let's go over those. So in the cerebrum, we have something known as lateralization, hemispheric lateralization. That means we either use one side, one lado, or the other lado, right? So one side or the other side. Now, which is the side that you use? How many of you are right-handed? How many of you are left-handed? Only one person in the classroom is left-handed. Lucky you. 2. What side of the brain do you use? The right or the left? Well, if we're talking about motor, from the opposite side of your hand. The hand that you use, right? If you're left-handed, right? We all use, as a majority of percentages, we use your left cerebral hemispheres. Okay? That one is known as the dominant hemisphere. Why is it so dominant? Because in there you control what? Language. And if you think about it, it's just not a word. I can tell you language, reading, writing, math, and logic. We're done. Keep going to the next. No. Why? Why? Why is the left? Remember, there's always a why for everything. Why language? If you think about it, because you think in language. When you're born and able to communicate with other things, other humans, you need to learn a language. And sometimes in your lifetime, you can actually need to learn at least 2 or 3 languages. Especially here in Miami, almost everybody speaks what? 2 languages. Does that make sense? So how long does it take you to learn a language?
3 years.
About 3 years, more or less, 3-5 years, depends on the individual and the surrounding. So language takes a while, so you're being trained on it. And you go to school to learn a language. Now, what about reading? Have you been trained in reading? If you think about it, how are you going to communicate with the internet? How are you going to communicate with books and stuff like that? Nowadays, you can actually listen to a book, but, it's not that common, right? Not all books are actually audible books. So you have to train in reading. Yes? At least all the way up to high school, right? You have to do the reading. And actually, even on college, I think you do some reading. What about writing? The same. What about math? The same and worse. They've been teaching you to do multiple sets of maths, right? To less complicated to all complication, right? That is because you spend a lot of time. So why is the left more dominant than the right? Because you used it the most. Does that make sense? Is the predominant lobe for these things, for language, reading, writing, and math. Why? It's overall predominant in both right-handed and left-handed? Because you're being trained it the most. So those of you that are lucky enough, you can have a right cerebral hemisphere, but that is basically for what? Visual and spatial skills. We all get that because we were born with the capacity of sight, almost all of us. Intuition. How many of you have been trained with your intuition? How many people here have been trained with intuition? You guys know what intuition is. So intuition is the part that you read a question, you answer it, and then you say, no, that cannot be right. Let me do something else. That's not intuition. That's you messing things up. Or sometimes some word or some voice comes into your mind and says, don't go there. And if you go there, something is going to happen. And guess what? You go against that, you go there, and something happens. Or don't make a right turn. You're going to have a car accident or something like that. That's your intuition talking to you. Or you have a bad vibe when you meet somebody. That is most likely your intuition. There's something that your body's perceiving, but you logically do not understand it yet. Does that make sense? So we have now been trained on that. Whenever you teach a lot of logic into individuals and a lot of math, a lot of sciences, that intuition is kind of like kicked out. Because you relate 100% on what?
Facts.
On facts. 100% on data, which is good. Because data can be what? Replicated. We can use data for it. But intuition? No, that's independent. And it changes all the time, correct? Yeah. The other hand is, well, we talked about logic on the left hemisphere. What is logic? Most of the time I see, I hear myself saying here in the class, that's logic. That's common sense. Or maybe common sense to you, you may say, but not to me. Because logic comes with what? With experience, with understanding of the language, with understanding the writing, understanding the math, understanding the different path. And little by little, that logic, it will kick in. That common sense that people say. So the more you know, and the more different ways that you can see a problem, you will have a better what? Understanding, a better logic to things, or better problem solving, okay? Techniques. So on the other hand, right hemisphere, you have your emotions. How many of you have been trained with emotions? How many of you go to school, this is a class that says emotional control? It's definitely not funny because think about this. What controls you and the capacity to acquire that 100% efficiency of your brain power is what? Your emotions. So if you don't know how to control your emotions, you most likely are not going to be able to function at your best capacity. Does that make sense? If you feel sad, are you going to study well? Are you going to do a test well? If you're nervous, no. If you're happy, things will go happy, right? But you say, oh, I have a bad day, but you keep going happy. That's a good state of mind. If you read something and say, you look at the picture and it's like, oh my God, that brain looks horrible. There's no way that I can ever learn this. And guess what are you doing?
You're learning.
No, you're predisposing yourself not to learn. You're blocking yourself and that emotional state. So we should have a class just about dealing and controlling our emotions, if you think about it. This is a little bit out of anatomy, but I'm just trying to get a little bit of psychology into you guys. All right? Now, artistic and musical skills. How many of you have spent at least 1 or 2 years doing artistic or musical skill jobs or work?
Yeah.
Where? High school? Yeah, I was 2 years in high school, right, doing drawings. You can tell that didn't work. Music?
Yeah.
And the part of music is changing because as the environment changes, we're changing. All of us listen to music every single day. Almost all the time, yes? No. Whether we like it or not. If you don't have a phone that connects automatically to your car, and you can select your radio station, you have a radio station, or the songs, or YouTube, or whatever it is that you listen to, Spotify, Pandora, whatever it is. But these songs are now more common, so songs can actually influence your daily life and your daily behavior. If you think about it. Wake up in the morning, you feel sad. What type of songs do you like to play? Sad music. Why in the name of God would you like to play sad music when you feel sad? To what? What do we call this? Masochist. Why in the name of God are you being a masochist with yourself? If you feel sad, what type of songs are you supposed to play? Happy songs. Right? If you feel happy, would you play sad songs? Unless you're too happy that you want to get out of the place that you want to be and you want to get out, right? So you want to come down and relax. That's when you do those things. So this is just about being controlled. And sadly, through TV, through multiple media, implementation that we have all surrounding us is changing the way that we act, that we behave, and that we think. Even changing our own personality without us not even knowing about it. Does that make sense? All right. So recognition of faces, you're not good or bad at anything that you do. If you're bad at one thing, guess what you gotta do? Keep trying. But I'm still bad. I don't care. Keep trying. It may take you 10 years, but you're gonna be good at it. Why? Because you're being what? Persistent. And life is not about reaching a goal. Life is about being what? Persistent. You are able to achieve anything you want in life as long as you are what? Persistent in what you do. Whatever it is that you choose. Switch up. And finally is what? Voice.
Like that.
All right. You like it? So we're done with that part. That was just the intro of it, okay?
That was good.
Did I get your attention?
No, you hooked me for sure.
Awesome. So, in the brain, you're going to have two hemispheres, and those hemispheres are going to be divided by the longitudinal fissures. The fissure is the deepest one. That's going to separate both of them. On the surface of the brain, around each surface of the brain, around each lobe, as I'm drawing here, you're going to have something known as the cerebral cortex. I mentioned it a bunch of times. And that's where you have your gray matter. That's actually the processing center. That's where you have all your neuronal connections, almost all your neuronal connections. You also have different convolutions. And these little convolutions that you have are gyrus and pleural gyri. And you have the little indentations or shallow grooves. These are known as sulci. Okay? So what are the lobes in the brain? Well, you have frontal lobe, count it, number 1. Parietal lobe, count it, number 2. Occipital lobe, temporal lobe, and insula. Wait, I heard all of it, but what about the insula? Well, the insula is a deep lobe within the brain. So it's deep. You cannot be able to see it unless you open the brain up. Okay? So most likely, a question is going to come from there. So the insula is the deepest of them all. It's a total of what? How many lobes? Yes, 5 lobes. Now, why do we need to really talk about the insula? Insula is not important. Who cares about it? Okay, here we go. Let's see if you care or not. Would you like to taste your food? It's gustatory. It receives information from taste receptors. Now, visual cortex. Would you like to be able to provide visual information as well as maintain equilibrium when you walk? If you're enjoying being drunk all the time, that's fine. So, and then, hold on. Do you like to smell things? That means you receive what? Information from the smell receptors on the roof of your nose. Again, remember that this olfactory cortex, or this olfactory nerve, is the only one that does not passes through the thalamus. That's the exception. So those 3 things, right, that we mentioned right now, they're part of the what? Insula. So that's a lot of work. All right. So what are the other ones? Now we have the auditory cortex, which is mostly on the temporal lobe. Okay, that's where we perceive all the information from hearing. You also have short-term memory on the temporal lobe. Okay? So you have auditory association areas, because one thing is to hear, and the other thing is to be able to listen and interpret the information that is being said to you, correct? There's a big difference. Sometimes people say something to you, and then you have to interpret their words to see what they truly said, correct? What's the meaning behind all this? It was those type of words that got to my brain impacted me in another way, and you start finding information around your brain. If I say beach, how many of you can picture the place? Sand, okay? Describe to me the events, just a little description. Sand, beach, palm trees. Give me just a little event of what you're picturing.
Wave.
Where were you at that time?
In DR.
In DR. Those words, and each one of the words that you're perceiving, that you're hearing, is triggering parts of what? Of your brain. Where? Everywhere in your brain. Temporal, occipital for visual, and then parietal for long-term memory, because you're able to receive that information. The picture comes out to you. That's stored in the parietal lobe. Okay? And then if I tell you more, can you remember the names of the people that were with you? Okay. Can you remember a special song that was played that day? Wow. So you stored all that information and you didn't even notice. Can you remember a specific dance that you did that day if you did, right? Or a specific game? Or probably a smell, right? Or probably the perfume or the clothes that you were wearing. Or the words that, or the conversations that you have with somebody. All that information is being what? Collected in your brain. And you have the capacity to access the information only if you concentrate and you want to. Okay? Huh? You don't picture a smell. The smell will come to you. Okay. Can you imagine? Okay, imagine right now the smell of coffee. Can you feel, can you interpret the emotional state of coffee into you? Some people will go like, others will be like, oh, right? Or your special perfume. Yeah, guys, you have memory of how coffee smells, how perfume, especially perfume smells, how lemon smells, right? How do you know a different type of smells? How a rose smells? Because you already smell it, and that is already stored within your brain. So all you have to do is pull out it again, because that is stored in there. Okay? The auditory is temporal lobe. So the association areas that we're trying to get here is that you're able to associate those words or the information perceived to any other portion or lobe within your brain and gather all the information so you can interpret it and send a command out. All I'm trying to say is that you process information in a really fast amount of time. Okay? And that goes all the way through. So on the parietal lobe is mostly for a long-term memory. So all memory that you've been stored for over a year period of time, 3 to 6 months over that. So that is a long-term memory, and most of this is somatosensory association area. What does that mean? Somato means your body. Sensory is all the sensations, right? The pain, touch, and temperature perception you're perceiving from your body are associated and interpreted, okay, in your parietal lobe. In other words, if you don't like the cold, it makes you feel bad. And that is going to cognitively affect you. And you're going to be, oh, let's go to this place, and this place is about 15 degrees. You'll be like, I'm not going. Automatically. You don't even know what you're going to expect there, but I'm not going. Does that make sense? Because, again, even the perception of the stimuli on your surroundings, and that's why the surroundings affects us, because we interact with them, are able to change our perception. So almost all sensory information goes all the way through your thalamus, and the main pathway or relay is going to be to the postcentral gyrus. That's where almost all sensory information goes through, the postcentral gyrus. Once you make your association into the different parts of the brain at the cortex side, that information goes out onto the precentral gyrus, which is this one is now part of the frontal lobe. Precentral means what? All your motor commands. So all the motor commands that you're going to send out, like when you step on a nail and you retrieve your feet, or when it's cold and you start shaking or something like that, or you put on a coat, that is all coming from your precentral gyrus. At the end, you have your frontal lobe, which is what? Your personality. It makes you who you are. It's the one that dictates when to do things, when not to do it, how to express things, how not to express it, how to inhibit things, and how to let something else go. Does that make sense? So is it okay to come into the class, I don't know, with a bikini? No, it's not right. You all say different things, but in your brain, it's weird, right? Because it's not used to it. But if a lot of people start coming in bikini, guess what? It's going to be used for everybody to come in a bikini because there's no problem with that. In the frontal lobe, we have a prefrontal cortex, that's the center for intelligence and rationalization. And here's another one speech. How do you become rational? How are you a rational individual? Because you use your reasoning, correct? Now, when you are affected by your mood, you cannot control your mood or your behavior. Would you become rational or irrational? Irrational. When you become really mad at somebody, you may love that person to death, but you can get really mad at somebody and you can end up doing what? Killing them, right? Strangulating them, right? I mean, there are people who love each other and they said, well, if you're not with me, you're not with anybody else, right? You want to stay away from those things. Anyway, but, I'm just saying that when it gets heated, you lose control. That's why I said you need to have what? A class about what? Controlling the emotions, right? So we all can behave as rational individuals, right? Now we have the Broca's area on the frontal lobe. Broca's area is known as the broken speech. It's the one that controls muscles of speech. So what is broken? Well, the way that you articulate the words. So you're able to listen because your problem is not on the temporal lobe, right? So I can say to you, hey, good morning, how are you doing? And you want to answer me back. Like what? He's doing fine. He's going to say, you get it? It's a complete broken speech. It's completely distorted. Have you figured out, like kids, when you're born? When they start talking, how do they talk? With a complete broken speech. They hear you, they understand you, even though you think they're not. But guess what? As they progressively develop, little by little, that broken speech becomes into a half of a word, and then it becomes a full word, right? First is a vowel, a couple, half a word, and then a full word later on, right? Because this area of their brain is developing, correct? But if you have an accident, that broken area can actually get damaged, and you won't be able to communicate. The next one that we have here is on the temporal lobe. This is another one that I'm going to cover, but it's later on the slide. And this is known as Wernicke's area. The Wernicke's area is a disease mostly found on alcoholic individuals. It's called Wernicke's and Korsakoff. Anyway, Wernicke's area is a word salad. Means that they're able to modulate, right? They can talk normally, but they're not able to do what? Hear. Well, they hear, they just don't listen. They don't interpret. That association area is broken. So if I say to you, hey, how are you? How was your day yesterday? And probably you're saying, or you're thinking that I'm asking you something about here, and you're going to answer based on, oh yeah, I like the PowerPoint. And definitely that looks nice, the way that you presented it. What? Nothing to do with that ask, correct? And that's how people with Wernicke's affected area happens. That's how they come up. So, parietal occipital sulcus. We're not going to talk about the different sulcus. You have your central sulcus, and you have your lateral sulcus. So these sulcus you really need to know which one goes where and what do they separate. So a lateral sulcus will divide your temporal lobe from the frontal and occipital. The central sulcus will divide the frontal from the parietal, and the parietal occipital, it tells you what it is. So there's other structures when you separate both hemispheres, like for example the cingulate gyrus, and this is just for the lab. But you have this one which is called the corpus callosum. Why do we really need to learn about the corpus callosum? I believe because it contains tracts that can carry information between both what? See? Between. Both. So how do you are dominant on the left, but you're able to use the right as well? Because of the corpus callosum. If you damage your corpus callosum, guess what's going to happen? You're going to use only one hemisphere. Yeah. Yes, you are. Now, are there individuals that actually can survive by removing a full hemisphere? Yes. Understand this. Both hemispheres are capable of doing any job that the other one does. It's just that one is more predominant in what they do, or more specific in what they do, and the other ones don't. It's like you and your right and left hand. You break your right hand. How do you clean yourself? There you go, and you learn. If you were to be in a car accident, and God willingly that never happens, you lose your right hand, guess how you're going to do? You're going to learn how to write and do everything with your left hand. So if one brain or one section of the brain or the hemisphere is damaged, the other hemisphere will take over eventually. So thalamus is your primary sensory relay center or station. So here I'm just showing you what the diencephalon is, which is, we said it was thalamus. So anything that is hypo or epithalamus, this area right here. And you have your brainstem, which is your pons. Okay. Mesencephalon, and medulla oblongata. Okay. So how do we actually see that cerebral cortex? Well, I draw the cerebral cortex here on the outside, right? Now, if you look here, I just made a cross section that is here. And then you can see that that cerebral cortex is only what? On the outside, right? Just like I'm drawing right here. Does that make sense? The rest of the inside of the brain is most likely what? White matter. So when we refer to cerebral cortex expands on top of every single one of your brain lobes. Okay? And how do you communicate each lobe? How do you associate them one to each other? Visual, auditory, short-term memory, long-term memory. How do you make them connect? Because inside that white matter, you have connection fibers that communicate everywhere inside. Just a bunch of cables. Okay? And we're going to talk about that one. So parts of the ventricles. Inside the brain, these ventricles are known, well, they are actually hollow structures. What does that mean? They're empty spaces. But these spaces are filled with a specific liquid or fluid that is known as cerebral spinal fluid, right? Which that expands all the way from the brain to your spine. And what are the structures of your ventricles? You have your laterals, you have your third ventricle, you have your fourth ventricle. Those are your ventricles. Now, what structures allow for the fluid to communicate or circulate actually across between the brain and the spinal cord and back? That is your interventricular foramen, right? So from the lateral into the third, from the third to the fourth, that is mesencephalic aqueduct or aqueduct of Sylvius or cerebral aqueduct. That's how your lab teaches you, cerebral aqueduct. Okay? And then lastly, out of your fourth ventricle, you have your what? Central canal, which is the one that you find on your spinal cord segment in the middle. You guys remember this kind of drawing, right? So this is your central canal. Okay? That spans all the way out. So, what structure will separate both lateral ventricles? And actually, you saw this on the lab as we dissected. And this is known as the septum pellucidum. You guys remember that one? It was a thin sheet. Some of the time, like I cut it through. It was a really thin sheet that separates both of them. Okay. So how do we make this circulation takes place? Well, we know there are 3 meninges in your spinal cord that expands all the way to your brain, right? And those were the what? Pia mater, arachnoid, and dura mater, right? From inner to outer, or outer to inner. Now, that's the same one that expands from the brain all the way to the spinal cord, or the spinal cord to the brain. It's only one. Now, on the subarachnoid space, so in the arachnoid, there's one below. In that subarachnoid space, which is this space right here, this space is filled with what? It's right there, CSF. So it circulates not only through the ventricular system, through central canal, but as well as into the what? Subarachnoid space. That's where you find your CSF in all these structures that we just mentioned. Whenever this CSF is being used, because as you use this fluid, the fluid contains ions, right? Sodium, potassium, chloride, glucose, right? So this fluid comes from where? From your blood plasma. From your blood plasma. There's no red blood cells, right? There's barely minimal or no protein at all in there. So we call this an ultrafiltrate of blood because it's really being filtered to really tiny molecules like what? Like the sodium, potassium, and the water, right? Just tiny ions. So whenever you use these ions within the brain, okay, whenever your brain uses or sends an electrical impulse, there's always going to be what? Waste products, like too much potassium, too much sodium, right? And that has to be in a constant circulation like a river. Imagine a river, right? So whenever you have excess of that CSF, how are you going to get it out of your brain and spinal cord? Because if you leave it there, excess amount of CSF, what's going to happen to your brain? You're going to compress your brain. Your skull is not going to expand because it's hard, correct? Your spinal cord, your vertebral column is not going to expand because it's bone. So what's going to get compressed is the gelatinous structure, which is your brain and spinal cord. It's going to get compressed. So what's the escape? The escape is through the sinuses, dural sinuses. So what are those dural sinuses? Dural sinuses are not more than veins, okay? So here are your dural folds. So within the dural folds, you have your superior sidal sinus and your inferior sidal sinus. Again, they're just venous system. They drain excess amount of CSF. Where to? Well, into the venous system of your body, right? Jugular vein, right? All the way into your heart. And then now becomes part of what? Your blood. Okay? Because remember we said it's a filtrate of the blood, correct? Now, what is the falx cerebri? It's a fibrous tissue which is part of your dura mater. When you actually took out the dura mater out of the brain when you were dissecting it, that dura mater had a little indentation in the middle, and that is known as the falx cerebri. So that one allows for a separation of both hemispheres, the right and the left. Where does the falx cerebri sits? It sits in the fissure. Remember the fissure? In that longitudinal fissure, that's where it sits. So when you remove that, you expose the longitudinal fissure. And then we have another one which is known as tentorium cereveli. If I remember this, I remember the word tent. Tent is like a roof, right? So it's the roof of your cerebellum. So hence the name tentorium cereveli. Okay? So it divides your cerebrum from the cerebellum, or your cerebellum from the cerebrum. Okay? Now, how does that fluid circulate? Right? And if you look at the fluid, right, what makes the CSF? What type of cells makes the CSF? I'm going to highlight choroid plexus, but what type of cells? What's the cells that makes your CSF? We talked about this ones already. These are known as your ependymal cells. When you have a group of ependymal cells, right? When you have a colony of ependymal cells, they make what we know as choroid plexus. Okay? So these ependymal cells are going to make your CSF. Your CSF is going to flow, and you can follow the arrows, right? And it's going to flow from the lateral to the third, from the third here, right? This is the third, to the fourth. This is the fourth. And then from there, it's going to go out laterally, right? All the way through here on the subarachnoid space. Or it's going to go to the central canal, all the way down onto L1 and L2. That is where your solid segment of your spinal cord ends. And it's going to go into your subarachnoid space again. Does that make sense? And all that is going to circulate around both your brain and your spinal cord. Okay? So what is the function of this cerebrospinal fluid? It cushions right? It supports the brain because it gives them what? Nutrients, chemical messengers, and even takes out your waste products. Okay? Everybody got that? So how do we get that X amount of CSF out of your subarachnoid space into your sinuses? And that happens around here. Okay? What is around here? These are known as arachnoid granulations, like tiny granules. Okay? So the fluid goes into the granules, and the granules have bigger pores, and the fluid can actually dissipate into the sinuses. Okay? Now, the brain gets blood from the rest of the body, correct? And that blood, you have oxygen and nutrients. But the blood can actually be contaminated. How many of you have gotten sick? How many of you have gotten the flu? Right? Now, the question is, except you, how many of you have gotten an infection on the brain? Meningitis or encephalitis? No one. Why is that? Because you have something that protects you, and that is your blood-brain barrier. In other words, it's in the blood, between the blood vessels and your brain, and creates a barrier. What makes that happen? This type of cells, known as astrocytes. Osteocytes are in the bones. So, see, meningitis and encephalitis can happen because of a viral infection, can happen because of bacterial infection, but it's highly uncommon. Why? Because of the astrocytes populations that you have. Now, the clinical application of this is, well, decrease the amount of infections as well as tumors and masses. So, brain tumors, they tend to arise from either your meninges, right? Pia mater, arachnoid, and dura mater. But most of the tumors of the brain come from glia cells. And so the name is gliomas. So gliomas are the most common type of brain tumors, right? And what they do is they disrupt the brain barrier of the brain, and as well as when you give chemotherapy, that kills your astrocytes and disrupts the blood-brain barrier as well. Okay?